Hello everyone. Welcome to the course of Internet of Things, in short IoT. In today's class, we are going to discuss a concept called Hello everyone. Welcome to the course of Internet of Things, in short IoT. In today's class, we are going to learn a concept called communication models in IoT. So, what are these communication models in IoT and what are its APIs we are going to learn today. Okay. So, first, let's see what are these types of communication models. We have several types of communications models in which the first one will be request and response. Okay. So, this request and response will be majorly between a client and a server. So whenever a client want to communicate with the server, so the client sends a request to the server and the server responds according to the request. So whenever the server receives the request, it decides how to respond, and based on the request sent, it will fetch the data, uh, and it prepares the response and send it to the client. Okay. So we have a model in the diagrammatic representation. So this is how a client communicates with the server. So this is a client which sends the request to the servers, and the servers, through a process, it will go and fetch the response from the database. So this is the database. Okay. And once the data is fetched from the database based on the suitable request, it will prepare the response, which is in an encoded form, and this response will be sent again to the client. So it's a kind of request and response model. So this is applicable in IoT as one of the model. Coming to the next model is an publisher and subscriber model where it contains publishers, brokers, and the consumers. Okay. So publishers are nothing but they are the source of the data. So these particular publishers and the consumers, in between both of them, there will be an broker who will be managing all this communication. So brokers are responsible for accepting the data from the publisher and send it to the appropriate consumers. Okay. So let's see how this broker model or this publisher subscriber model works. So this is how a publisher and subscriber will be communicating with the help of a broker. This broker can be for example, it can be an MQTT protocol. Okay. So whatever the publisher publishing the data, all the data will be handled by the broker. And this broker, based on that particular data given by the publisher, he will be, it will be sending it to the subscriber. So here the subscriber can be our consumer as well. So this is the publisher and subscriber model. Coming to the third one, it is push-pull model. So push-pull model is completely related to the data publishers, consumers, and data queues. So as the publisher publish the message or data, okay, that particular message or data will be pushed into the queue. Now, the consumers present on the other side, they will pull the data out of the queue. So this particular queue mechanism will be acting as a buffer for this particular data or the message sent by the publisher till the consumer or the uh, subscriber takes that particular data or pulls that particular data. Okay. So this queues, which is a buffer, which will be helping in uh, a decoupling kind of mechanism between the producer and the consumer. Okay. So the major advantage of this particular queue is it will not allow any kind of mismatch rate between this particular publisher and the subscriber. Okay. So whatever this publisher pushes the data, that will be stored in the buffer and it will be pulled by the subscriber or the consumer whenever required. It is as simple as that. So coming to the push-pull model, this is how the model looks. So there will be a publisher, and whatever the data is sent by the publisher will be stored in this particular buffers, and that will be retrieved or pulled by the consumers at the other end. Simple concept. Okay. The next one is the exclusive pair. So this is like an give and take policy. So it's an exclusive pair is nothing but it's an bidirectional model which is having an full duplex communication among the client and the server. Okay, so the connection is constant. It always remains open till the client sends a request and close the connection. Okay, so let's see the diagram how it works. So see, so there are so many connections between the client and the server. So initially, a step-by-step process will be carried out for establishing a connection and closing the response as well. So first, whenever the client sends the data, it will be considered as a request to set up to connect, that will be given to the server. Once the server gets the request, okay, so the response accepting request will be sent to the client. So now the client knows that the server has accepted the request. Once the request has been accepted, the message from the client to the server will again go, and what type of message, whatever the client is expecting, that particular data should be sent from the server. Okay. So again, what happens? The message from the server to client goes based on the request sent by the client. Okay. Once the data is transferred to and fro, okay, there will be a last connection called connection close request. That connection close request will be sent by the client towards the server. Once the request is received by the server, the connection closes the response. Okay. And that response will be given to the client as well. So this is a full duplex and bidirectional communication in an exclusive pair model. So all these are the communication models used in the IoT depending on the applications. Now coming to the IoT communication APIs. So we have several protocols like HTTP, MQTT, COAP, and so many protocols which will be used in communication between the applications as well as the IoT devices. Now let's see some of the advantages of communication APIs. So so the developers, whoever developing these particular applications, okay, so a lot of time will be saved in the process of making or developing these particular products as well. Okay. And coming to the another advantage, the development of this particular process is very much easier. And uh, coming to the security, enhancement of security is much more ensured in these particular kind of devices at the time of communication. And these communication APIs are also built to be extremely scalable. Okay. And integrating these kind of communication APIs into the IoT applications are much more easier compared to any other uh, protocols or the applications. Now, types of communication APIs. So the first API can be considered as REST API, REST API. So it is one of the popular APIs among the IoT communications where it is used to access and alter the IoT data and devices, allowing developers to create novel IoT powered apps. So whenever the developers need to access or alter the IoT data, they can also do it with this help of REST or REST API application interfaces. Okay. Now, coming to the WebSockets, this is another API. So it's a protocol that provides bidirectional as well as real-time communication. So these particular bidirectional and real-time communications obviously happens between the client and the servers. Okay. So this particular WebSocket is mostly used in all kind of communication APIs in order to provide low latency, real-time data streaming. Okay, so these which is very much important and essential. So this particular kind of features can be implemented with the help of WebSocket in the IoT devices as well as the cloud services. Okay, so unlike HTTP, WebSocket will be having or establishing a connection between the client and the server, and also allows the real-time communication without any need of constant polling. Okay, so it makes an perfect for an IoT or the Internet of Things applications for these kind of real-time data updates like monitoring and controlling the IoT devices. Coming to the next protocol, we have CoAP protocol, which is nothing but Constrained Application Protocol. It is used in communication APIs like resource constrained devices and networks. Okay. So mostly it is considered as a simple protocol for manipulating IoT devices which are controlled over internet. Okay. So this is a particular the special purpose of this particular protocol is it sends messages in the tiny sizes with a minimum header information. So, whatever the IoT devices which are processing with less power and memory, this is the best suitable protocol for those kind of IoT platforms. At last, we need to visualize the MQTT, which is very much important and essential in IoT applications. First of all, MQTT stands for Message Queuing Telemetry Transport. Okay, so it's an lightweight messaging protocol used in IoT communications. So these kind of protocols helps in linking the devices, IoT devices to the cloud. Okay, so it is very much simple to use and it's an very much advantageous protocol in using these IoT applications. So this particular MQTT majorly follow publish and subscribe a model, which where this particular MQTT acts as a broker, okay, in between the publisher as well as the subscriber. Okay, so AWS, Azure, Google Cloud, all these communication platforms will be using this MQTT protocol, which acts as a broker between the publisher as well as the subscriber. So these are some of the APIs or the protocols which are majorly used in IoT applications, and what we have seen till now are the models which are widely used in the IoT.